graphing exponential functions. So exponential functions will look like this. They'll be flat, and then they'll grow really tall, really fast. And on that flat side, it'll be very close to an asymptote. And it is a horizontal asymptote. Or it could go from really high to really flat. Again, with the asymptote on the bottom. This first one is considered a growth because it's getting taller from left to right, and the second one is considered a decay. So that's just kind of the shape of the graph that we'll be seeing today in Delta Math. So the exponential functions formatting, f of x equals a times b to the x minus h plus k. To graph the function, you will start at 2 points. 0, comma, your a value, and 1, comma, your a times your b value. After you plot those 2 points, you will need to apply any transformations and your transformations will be if there's anything added or subtracted to the x, and anything added or subtracted on the back of the function. So anything added or subtracted to x, and this is the same process that we did with our square root functions. A plus is going to lead you to the left, and a minus is going to lead you to the right. If it's on the end and it's the same size as the A and the B, then that plus is going to lead you up, and the minus is going to lead you down. And the last thing we'll need is the horizontal asymptote which is going to be y equals your k value. And then y equals 0 if there's not a number back there. All right, so we're going to look at a couple of examples. We're going to find the start. Zero A, 1 A times B. We're going to apply the transformations. And we're going to find the asymptote. All right. So here's the function f of x equals 2 times 1/2 to the x minus 4. So I'm going to first identify A as my first number. B is always the base or the number with x as its exponent. So my starting points will be 0, comma, my A value, so 0, 2. And my second point is going to be 1, comma, I'm going to multiply A times B. So 2 times 1/2 equals 1. The transformations for this function, nothing is added or subtracted to x, so it doesn't go left or right any, but it does move down 4 because of that big minus 4 on the end. And my asymptote is going to be y equals that same number. So I'm going to use -4 as my asymptote. Okay, how's that going? We're going to do like three or so more examples so that you get pretty used to it. And then I'm going to show you what it looks like on Delta Math. So right now we're just finding this information and writing it down, but in Delta Math you're going to have to apply it to a graph. So we'll look at that together in just a moment. Okay. So example 2. Okay, so for this start, we use 0a and 1a times b. So I chose this example specifically because I don't have an a value. I always have a b value because b is our base with x as the exponent. So you'll never not have a b value, but you might not have an a value. But we do want to put a number there, and since we're going to have to multiply these together, we want to use a 1. 1 times 3 won't change the problem. So we'll have 0, 1, and 1, comma, 1 times 3 is 3. We will then apply the transformations. So I have one transformation up here with x, and then I have one transformation off on the back here with that 5. So anything attached to x, it's going to move along the x-axis, either left or right. And remember, you don't trust your x's. So although that's a -1, which you would think would go left 1, it's actually incorrect. We're actually going to shoot this to the right 1. This is going to shift it up 5. Your asymptote is always that back number, and if there's not a back number, it's going to be 0. You always have an asymptote for these functions, a horizontal asymptote. Let's do another one. Y'all doing okay? All right. So 0, A, 1, A times B. So A is 2 and B is 5. So 0, 2, 1. So I'm going to multiply 2 times 5 is 10. But once I get those original points on the graph, I am going to have to apply the transformations and this graph has a transformation. It's going to go to the left or the right 3? To the left. And I know that's odd, but it's just the way it goes. So once I get those 2 points on the graph, I would have to shift them both to the left 3, and we'll look at that in Delta Math in just a moment. So the last thing we need is the asymptote. There is always an asymptote. But there's not a number added or subtracted here on the end. So we're just going to say that it's 0. Y equals 0 if there is not a number there. Would you guys like to see another one, or are you ready to look at the problems in Delta Math? I want to do at least one of them with you so you can see how it works. Are y'all okay with that? The plan?
Yes.
Okay. I'm going to stop my share for a second. Delta Math.